This is Rebecca Noel performing Lab 6 for Mr. Pushpa's Chemistry 2 class. On buffers. Buffers have an incredible ability to absorb acids and bases in order to keep the solution's pH from changing. This experiment will allow students to discover a buffer's activity and ability to be unchanging when exposed to varying pH levels as a result of acid and base introduction. It will also require the use of titration techniques in order to define the concentration of acetic acid. Hypothesis. The buffer will be able to maintain its stability up to a certain level of acid and base introduction. The buffer will be able to maintain its neutrality, but will eventually be overcome by the changing pH levels of the various solutions. Also, the buffer may be more effective in certain solutions. So, this experiment requires the use of household white vinegar, white paper, distilled water, scissors, well plate, hydrochloric acid, sodium hydroxide, and pH test strips. The first step is to place 2 milliliters of white vinegar into wells A1, A6, B1, and B6. Then add 4 drops NaOH to each well and stir. Next, we will dilute 6 moles per liter of hydrochloric acid to 0.1 moles per liter of hydrochloric through the addition of distilled water. To do this per instructions. And we'll do it for sodium hydroxide as well. For preparation, we cut the test strips, follow instructions as described, and record data. So after adding 5 drops of sodium hydroxide into each well, the solutions all turn bright pink. After stirring the mixtures, the colors remain the same color. Then HCl is added to the first well, making the pink color disappear. And after 8 drops, the solution is completely lacking in color. Conclusion. It is evident after performing this experiment that once a buffer is introduced to a solution that may be either highly acidic or basic, buffers quickly and effectively work to rebalance the solution. This is made clear by the color changes associated with the lack of, and respectively, the addition of a buffer solution. So buffers are found naturally in the human body, but they are also used in many areas of daily life. One example of this would be in shampoo. Shampoo contains buffers that balance out the alkalinity of soap that would otherwise cause chemical burns to the user's skin. Buffers are also used in diaper rash cream. Baby cream is designed with a pH that is a bit acidic, which slows the growth of bacteria, which would cause rash and infection in that area. So the objectives of this lab are to develop familiarity with the concepts and techniques of titration, to determine the concentration of acetic acid solution, to determine that the acetic acid-acetate ion pair can be used as a suitable buffer, and to observe how well a buffer can withstand changes in pH when dilute and concentrated acids and bases are added to the buffer, to observe the ability of water to act as a buffer. So we recall that acids react with bases and not with other acids, while bases react with acids but not with other bases. Only solutions containing both an acid and a base can resist the effect of both acids and bases. Thus, a chemical buffer solution must consist of a conjugate acid-base pair in reasonable concentrations, and the pH of a specific buffer solution depends on the weak acid conjugate base pair it contains. For this lab, we have a data table which is not meant to substitute a formal laboratory report. So We can determine the similarities and differences between various solutions. Oh my god, I should have voice lower.
It's how much
Oh,
time?
there we go, it's time.